Hey, hello everyone. So I'm Moshini from UTEM, and my faculty is Faculty Technological Jurulatara and Electric and Electronic. So I'm studying at UTEM Malacca. Okay, now I'm here to explain about the DC analysis circuit, and my group number is group 12, and my partner is Fadila. Okay, I'm here to explain about part 1, what I did. Basically, okay, okay. Before the part one, I can explain about the objective of this lab sheet. So basically, we did this lab sheet to measure the voltage, current in a DC circuit, and also to verify the Ohm's law using the simulation. Determine the relationship for voltage and current for constant resistance. By the way, verify of Kirchhoff voltage and also the current law. So this is the main objective to do this lab sheet, and moreover, the equipment we use to do this lab sheet is the most important thing is the multi-sim software. It's a very good software, and also our personal computer. The personal computer is basically to do our lab sheets and also now as well to record our recording to record our assessment. Okay, you can you can pause and study about the synopsis as well. Okay, okay. So this is the part one. To verify the Ohm's law. So as you see the procedures given, we should construct a circuit something like this, not to say something exactly like this in our multi-sim software. So I will show you that. Okay, so this is our part one circuit where, okay, this is where we have to set up the exact circuit what the lab sheet shows. Exactly the same one. Okay, you can see here. Okay, once we are done with that, okay, you can click the components from here, this side on your left hand side, and then you can set your ohms and also the voltage, ammeter, everything you can set up. This is the prop, and also the red color is the current. You can play, sorry, you can run the simulation and you can see the current flow, and basically you have to set the ground as well, and you can see the voltage value here. And then once you are done, you can stop the simulation, and also you can start doing the table where this is how we have to calculate the result for part 1. So the resistance is 100 ohm, and then calculated value also 100 ohm, and the calculations are here. To calculate the resistor, basically we have to use the formula V equals to IR. So when you want to calculate the resistor, it's voltage divided by the current. So that's the formula for part 1. You can see, you can pause the video and you can have a look here. Okay, as well as we need to do the figure 2, the same thing. Okay, actually it's not same, something similar to figure 1, but there is a difference between it, and you can do the circuit according to the procedures. You can read it slowly and you can do the circuit. So this is for part 2. So I'm going to show you figure 2 in my multi-sim. So this is our figure 2. The circuit is constructed as same as shown in the lab sheet. Okay, so the voltage you can change according to the lab sheets table, and also the V is the voltage, and the A in the blue color is for current, so that's called prop. And so once you run the simulation, you can have a look of the value of the voltage and the current. So you can change the voltage according to the table. So you will get the value according to the voltage. Voltage is a voltage that you are set. So once you are done with this circuit, you can anytime change the voltage according to the given values. And once you are done, fill up the tables. So we can pause the video and see the calculations that we are done. Since our time is just 10 minutes, I'm unable to explain every single thing. The table values, this is the table values, and the voltage and the current always directly proportional. If you didn't get something directly proportional, then it's something wrong with the circuit or with your calculations. So you can know from that. So that's all. Thank you. Part 2, my partner will present. Thank you.
Hi and Assalamualaikum. I am Nur Fadila binti Azhar from Group 12. We will explaining for part 2. For part 2, we will look at relative circuit. Okay, so this is the result that we got for currents, voltage, and so on. So I will show you how do we get this on multisim live. The measured voltage value for AB is 5.9459 volt. Meanwhile, for BC, measured is 4.0541. For AD, this is the voltage value for AD, which is 7.6744 volt. For DC, we got 2.3256 volt. As for VBD, through point B, point C, and point D. So basically, we need to minus this value, which is 4.0541, with 2.3256. So the total we got 1.7285 volt. As for VC voltage, basically the total current, which is 10 volt. Next, to measure sum of current at nodes, AB and CB is basically the same because R1 and R2 are installed in series. So the measured value for IAB and ICB is 27.027. For calculated value for IB and CB, we can use the formula I equal to V over R and calculate the value for IAB and CB. For IAD and ICD also imply the same concept, which is R4 and R3 are installed in series. So the currents at IAD and ICD are the same, which is 23.256 milliampere. Currents at nodes A shown here is 50.283 milliampere. We also can calculate this value by using the formula I equal to V over R, which is V is 10 volt and R is R total, which is 198.875 ohm. To measure voltage around the loop, for A, B, C, E, F, A, voltage go through AB, CB, and V total. So the total voltage around loop ABCEFA is 11.8918 volt. For loop ABDA, we will take the voltage at point AB and point AD and sum it. Total would be 13.6203 volt. voltage around loop BDCB will get a negative value because DC and BC have opposite polarity. So the total voltage for loop BDCB is negative 6.3797 volt. For loop ABCDA, the voltage around this loop we got 7.2406 volt. The currents at nodes A are basically the total current, which is 50.283 milliampere. Same as when the current exit the junction here at point C, the current value still 50.283 milliampere. The currents at nodes B we can see here, which is 27.027 milliampere. For current at nodes D, we can see also here, which is 23.256 milliampere. How do we get this value from calculation? It's basically we use this simple Ohm's law equation, which is I equal to V over R. Okay. Just put all the voltage value and resistance value inside the equation, and then we will get the same answer shown here. So that's all for lab 7 for part 2. Thank you.